Good morning, students. Today our topic is queue. It's second techniques in data structures. The queue is also an abstract data structures like stack. But in queue we have two ends for insert and delete. So one end is always used to insert the data, the name of enqueue operation. The other end is used to remove the data in the name of dequeue operation. The queue as a real-time example for the queue is as showing a figure, the car or everything in queue. People are waiting for getting the ticket in queue. And the same real-time example. So the queue follows the first in first out methodology. That means who first come, they get the service in first. That is known as first in first out methodology. The diagram 2 represents the queue structure. In queue we have a two endpoint. The two endpoints are used to insert and delete the data. So in the left side we insert the data, on the right side we delete or remove the data. This is the basic structures of queue. So next, what are the operations can be done using queue? So basic operations are enqueue and dequeue. The enqueues are used to store a particular item data in the queue. At the same time, dequeue is used to remove or delete an item from the queue as showing the figure. So read and push the data here, read and delete the data, get out from the queue. Then the supporting some other functions are listed here. First one is peak, is full, is empty. So the peak is nothing but it just shows the element at the top. That means it gets the element at front of the queue without removing it. It just displays the front element. Is full is a function. It returns yes or no, 0 or 1 as an output. It checks if the queue is full or not. Same as is empty function. It is also written yes or no output for the queue is empty or not. Also, the queue have two pointers, the name of front pointer and rear pointer. They have a two pointer, name of front pointer and rear pointer. So the front pointer is used to dequeue. So front mean nothing but dequeue operation for deleting. The rear operator pointer, the rear pointer is used to insert or storing the data. So the rear used in the functions of enqueue. So now we see the code of peak function. So peak functions already we told, it is used to display the data at the front of the queue. Okay, so this is the algorithm for peak function. Return queue front. So return queue front. It return the first element, a front element of the queue. The same algorithm implemented using C. Function name peak. It return queue front. As a queue, in the queue, what's the value stored in front pointer? It return the one element that is stored in the front element. The second one is full. So the is full is used to implement the queue. So using single dimension array, it is used to implement queue. We check for the rear pointer to reach the maximum size, to determine that the queue is full or not. Here we are using the one parameter in the name of maximum size. Each queue have some size, 10, 20, 30 like that. So after we reach the maximum size, we can't to insert the new element into the queue. So before inserting any particular element, we must check the queue is full or not by using the function is full. So here we write the algorithm step by using rear pointers. So the queue have a two pointers, the name of rear and front. So the rear equal to maximum size means it return true. Yes, the queue is full. It return false means the queue is not full. We have some place for the new element. The same procedure is implemented in C function. Here it return true or false. So this function type is full. The function name is full. Here the maximum size is already defined, maybe 10, 100 like that. So when the rear memory size equal to maximum size minus 1, because the queue memory value start from 0 to n minus 1. So when the rear value equal to maximum size minus 1 means yes, the queue is full, it return true. We can't to insert new element. When it return false, that means the rear value is small value when compared to maximum size means it return false, we can insert the new element. The third operations of the queue is empty. Here we use the pointer name front. It's a front is used to delete a particular element. So by using the front pointer, we can easily remove particular last item from the queue. For insert or check is full, we use the rear pointer. 2 pointer rear and 1 pointer front. So here when the front value is equal to minimum or 0 means the queue is empty. This is a simple condition. When the front is less than minimum value, here minimum value is 0 or 2 like that. When the front value equal to 0 means it return true. Yes, the queue is empty. We can't to delete no more data because the queue is empty. We can't to delete, there is no element, so we can't to delete any element. The same procedure is implemented in C language. So pool is empty. Here pool is the return type. So this function return true or false. So this data type is Boolean data type. So pool is empty, the function name. If the front value less than 0, the front value is less than 0 or any one condition is true, it return true. The front value is less than 0 means -1, -2, or the front value greater than rear. It means it maximum size is completed. Maximum size of the queue is filled. Then the front value again move to maximum rear. So it return true. Yes, the queue is empty. Return false. If 2 or 3 element is present means it return false. This is a basic 3 operations in the queue. The check is full, is empty, the first element displayed using seek operation. Then basic operation is NQ. The basic operation is NQ. So see the diagram. Already we told we have a 2 pointer rear and front. So the rear placed in insert function, the front pointer placed in delete operation, DQ operation. In the NQ, you can insert new element. In this example, I have 3 elements that are already stored in Q, A, B, C. So A is first inserted, B insert at second, C insert at third. So C is the last element. So in this condition, if you want to insert one more new element in the name of D, so what happened? The rear go to next place. The rear want to go to next place. It first identify the place for the new node. So after move to next level, we can insert the node D after C. There is no changes in front. There is no changes in front. So only changes in the rear pointer, because NQ happened here only. Then only we change the rear pointer's value. Just nothing but it increase the value by 1 and then insert the new values. This is a simple condition for NQ. So next one, QNQ. QNQ operations implemented in C. So here the rear value is increased by 1. After new value of rear, we insert the data. The first rear value increment by 1, the size is increment by 1. Then after increment of rear, we get the new value for rear, then insert the data at rear place. Okay, this is explained here only. Next one, DQ operation. So DQ operation is nothing but delete the first element. Delete the first element. So by using the pointer of front. By using the pointer of front. So see this example. This is my Q. My Q have a 4 element A, B, C, D. So rear point at NQ position. The front point at DQ position. So DQ delete the first element. It must or it always delete the first element only. That is known as DQ. So how can we delete? We delete the element pointed by front. Okay, we delete the element pointed by front. So the data get from Q using front pointer. The data, see the code. The data, we first access the data. Which data you want to delete? So we access the data by using Q front. So once the data are copied from Q to data, I can free the front. So the front position is go to backward from 0 to 1. So how it possible? Is simply front equal to front plus 1. If my front value equal to 0, means because Q is always starting from 0. 0 plus 1, 1. So front position now is equal to 1. Then it return the deleted element data. So the value A is copied to data. Finally you return the data value, that is the deleted element is displayed. Front now point to the next first element front. This is the operations of QDQ. Okay, listen the code. So before changing the position of front, we get the current data of the front. We get the current data of the front pointer. After that, we increment the front by 1 because the front go to new place. This is a simple basic operations of NQ DQ of Q.